Oh my god! Oh my god! That was bad, bud. I pressed the wrong button the whole time, Joe. That was bad, bud.
Hello world, this is Chris with Elevations, doing a fun video here today. This is obviously, as you can tell, some of our rocketry projects that we started doing. One of the team members in lockdown, that would be Joey, came to me a couple of weeks before Worlds and said he wanted to do a science project involving model rockets. And I said, hey, I happen to have everything you pretty much need to make that work. As you can tell here in the beginning of the video, we have a little bit of a disconnect on the engine itself. So part of the process is I was trying to get everybody on this team here to really understand how these systems work, how you actually launch, going through the troubleshooting process and making sure you have the igniter plugged in properly. Obviously, as you saw, I was doing that first so everybody learns how to do it safely. We did disconnect the safety mechanism and then we reconnected the igniter. And Joey here is here with the launcher and trying to make this work. Now you saw the video when we first started. There we go, launch number 1. The video when we first started, we were able to really test things out, figure things out, get all those launches going, and now I'm going to go through and show the individual videos, kind of a normal speed. You can see how all of that works. Now what you can see that just happened right here, I'm going to split over to the drone view. So this was their first launch. You can see that taking off in the drone view. And here, if you look real close, you can see the rocket coming back down with no parachute. Come to find out, when they were assembling this, I did not double check, but they taped the top to the bottom of this rocket. So when it came back down, it just came down as a missile. So part of the model rocket systems, you have 2 different sections. You actually have the rocket body or the fuselage, and then you have the payload on this particular one. So that's the top section. When the burn is done from that model rocket engine, it's supposed to have a little pop to eject the top payload section, and then that's where the parachute is allowed to deploy. Well, when you tape everything together, that's not allowed to deploy the way it's supposed to. So as you see here, it just came down as a missile and stuck directly into the ground, nose down. Surprisingly enough, it didn't get damaged as much as you would think. The nose cone itself had a pretty good sized break to it. One of the fins that Joey designed came off, but everything else seemed to be somewhat intact. So if we take a look at the launch with the 360 camera, you can see right here where the 2 different colors actually change on that rocket. That's the difference between the payload and the fuselage. So what he actually did is he put a piece of tape between the 2, trying to make sure everything doesn't fall apart. However, in that particular location, we do want it to come apart. So what you can see during the launch process is it takes off just as we hope. There it goes. But when we see it get up to the apogee, it does pop to be able to do the parachute deploy. You saw that right there on the screen. And then what happens is no parachute. It just stays together, and then you can actually see it come down and just missile right in the ground. It buried itself about 4 inches in. So right there, good lesson learned. The kids definitely enjoyed it, except for I don't think I'm going to be able to use that nose cone again. Okay, let's take a look at launch number 2. So this time one of the other kids was on the firing mechanism and Joey's holding his phone to record there. As you can see, we do have a nice little table on site to help set up our computer systems and drone controllers and everything else. He went ahead and launched that, and this is going to be launch number 2 with that double fin design. As you can see with Rocket 2, we actually had a parachute deployed. Now let's take a look at the rocket launch view through the Insta360 view. Here we go with rocket launch number 2. So the number 2 rocket has that dual wing design that you can see, or dual fin on the rocket itself. So this was designed by Joey with Team Lockdown. And one of the goals of this experiment was to determine what types of wings can potentially give us the highest altitude on the launch. We used all D12-5 engines, so it's all the same rocket bodies and all the same engines, but when they launch, we did get some different altitudes based off the different designs and some of these different angles here. The extra weight, I think, on this double wing definitely caused some issues on the total altitude, so this was the lowest flying rocket. Now let's take a look on the drone view of rocket launch number 2. Launch number 2. As you can see here, we went off a little bit to the left. We do have this drone holding at altitude to keep an eye on those rockets. And in the bottom of the drone, we have a recovery hook just to make sure if it does go off somewhere we don't want it to go, we can go ahead and grab it. And you can see the parachute did deploy as we wanted it to, and it did descend down to the parking area in a nice, safe fashion. You can see Joey and his teammate there running over to recover and check out the rocket itself. So again, this was our second launch in total, and it was our first successful parachute deploy. Certainly happy to see that one not come down as a missile, and because of the light wind we did have, it did move a little bit from our launch zone, but definitely not too far, and certainly within every safety factor that we needed. Here we are with launch number 3 with the Insta360 4K lens, and I'm going to slow this down to slow-mo so we can really watch this thing take off. Here we go. 3, 2, 1.
Wow!
That went wicked high.
And it came out, dude, that was so clean.
And launch number 3 from the drone. You can say that definitely took off at a higher altitude than all the rest of them. So this was Joey's specific design for a wing or a fin that he believed would be the best for altitude, because it kind of made the rocket itself do a little corkscrew on the ascent. And then here you can see with the drone view itself, we were able to capture, again, rocket number 3 with a successful parachute deploy, and it did return down to the ground successfully, and the team ran over there and recovered the rocket and the payload without any issue. You can see right there dangling in the bottom of the drone, that's our little recovery hook. Now let's recap the launches from the day.
Oh my god! Oh my god! That was that button? I pressed the wrong button the whole time, Joe. That was that button? That went really high.
That went wicked high. Now let's view some of the raw drone footage. This will be launch number 1, then launch number 2, then launch number 3, so you can see what it all looks like from the drone view as each one of these rockets launch. Now we achieved between about 650 and I think 1,000 foot with the different rockets. I do believe the dual rocket design was the lowest. The original control design that Joey made was the medium at about 768, and I do believe that slightly angled fin that allowed the rocket to rifle on the way up or corkscrew on the way up, that helped hold it as straight as possible, and I think they achieved about 1,000 foot in altitude. If you've ever done anything like this, or you have any cool ideas for our next fin ideas, certainly leave the comment below. Looking forward to doing some more of these projects throughout the summer with our teams. My name is Chris. As always, I do hope you learned something today. Like I said, drop a comment below if you have any experience in this. Like and subscribe below so you can see our future videos as they come out. Thanks for watching.